Okay, so I'm tuning the gauntlet that I'm using and creating this to the Mark 42. This is the shortest segment that I'm going to get using the puppeteering, solenoid puppeteering for the Palmer actuator. I'll turn around this way. I don't have that much lighting. So this is how it is. Permanent magnets is going to be localized onto the surfaces of this W bar, flat bar, and this is an iron. And I'm going to plant permanent magnets, nickel neodymium, alongside here. And each one will have it. This is at a segment lower than a segment, and another nickel neodymium set will be localized under there, another there. Once the nickel neodymium set is applied to the surfaces, mounted to the surfaces with resin and silicon carbide, then the following, and aluminum oxide, then the following shall be a stacked copper and aluminum coupled together in a stack in series, and that will replicate the same spot and the same part of the segment. So this ratio metric range from here to here, it shall replicate that as an overlay, and that is an overlay of these individual parts, and that should create the articulated actually solenoid repulsive behavior. So the diamagnetic repulsive force causes these things to move backwards like an actuator away from the permanent magnet and electromagnetic field. It also enables this to levitate as the fly on its own by self-repulsive force against diamagnetic repulsive force against repulsive force against the common, which is the aluminum, the common, which is the copper sheet, and the aluminum sheet, and the common, and the repulsive force, which comes from the permanent magnet, nickel neodymium. So as it stretches out and extends, there is the extension, and this is the latch for the extension to join to the palm. I'm going to be using puppeteering these rods as puppeteering for pulling strings of the gripping, grasping, and gripping of the hand. And as you see that it can open, this is the underframe, which is the subsystem of the engine that enables it to see how this is separated from the top, but it can roll, see at a distance, so the coil can be spun around these rectangles right here, horns. And the horns will repulse away the permanent magnet and repulse away from itself and move to stretch, to extend. And the armor shall be coupled over these horns, so the subsystem may not be seen visually, prospectively. The other side is I'm working on to finish to accomplish. The electromagnetic solenoid hold will hold it together for the metal to metal bond and to solid state. To solid state the armor, I'm gonna use a high gauge, about 1 point. I'm gonna use the last aluminum block at 1.8 of an inch, and I have a shirt on, so it's not allowing me to do it because it's pulling onto the shirt surface. But I'm doing it manually, and obviously you see I have my coil on here, so I'm just reducing its size. I'm gonna take it off and to allow you to see it. What I'm going to cover with horns. And I have these rods to enable me to puppeteer and to guide and slide each part from one another as the gauntlet itself of the iron resist. Now the hand unit that I'm going to do is a commutator because this is a stator. So a stator and a repulsive commutator at the same time. So the hand unit, the Palmer unit, I'm going to be using a quartz sphere to rotate within a magnetic field. And my hand parts that I have is going to be used as a commutator, and that the horns will be pointed towards the sphere. The sphere will have a filament of copper, aluminum, silicon carbide, aluminum BBs, copper BBs, silicon carbide, refrigerant fluid, a small proportion of cornstarch for the non-Newtonian elasticity. It'll have quartz crystals, it'll have gadolinium, and 300 iron and 100 iron, like mesh powder. And that will be used inside the system. That will be used within the magnetic field. So the horns will phase the sphere, which will be on a ball bearing armature. And it will be a filament of a quartz crystal, because quartz crystal is a sphere. It's two domes that are applied together and mounted with a belt to hold together. And the vibrations inside of the loose atmospherical environment will allow the collisions in motion, collisions of the BBs against the surfaces of the quartz crystal. And the quartz crystal will arc and fire to the copper and the electroflux, the density of the copper, which will act as an electrochemical battery. Not only act as an electrochemical battery, rotary crank power step up. Even though that this power step up, so within the magnetic field of the Palmer, it would synchronize the metal in the hands and synchronize the other parts of the coil. These rails will be as cathode and anode, and that will move this actuator that will be connected to the service from the copper with a single phase rectifier as a rail, electromagnetic rail gauntlet, which is not a rail gun but a rail gauntlet. And thus it will move in high speeds. It should repulse diamagnetic repulsive behavior and cause the aluminum at the bottom of the sphere to levitate as a fly. From its weight of the inertial mass, or weight of gravity in its inertial mass. Why? Because the sphere is electrochemical, and there in it, the filament is aluminum and copper, and silicon carbide, which is the flux, the magnetic flux, and also causes thermoelectric effect refrigeration. I'm also going to be using bismuth within it, as small bits of 300 Gs of bismuth, and 300 to 600 to 1200 bits of bismuth, and that will increase the thermoelectric effect or Pelletary effect refrigeration. At the same time, while in rotation and movement, I'm going to also add a flux of proportional powder, 1200 Gs of nickel neodymium powder, and add it within the filament of the crystal. And the thermoelectric effect, once it phases with the horns within the magnetic field, will electroflux the density, cause the thermoreactive pyroelectric effect of the quartz crystal. And the quartz crystal will electroflux the density of the copper, and the copper will send current and electric current and charge the aluminum. The aluminum powder mesh or foil mesh will also receive 10,000 nanos that will divide and separate within that atmospherical environment, thus increasing in electrolux and electroflux. The gadolinium, however, being phased within the magnetic field, will create heat. The heat will also create condensation. Condensation will also create moisture. Nevertheless, in the same environment as heating and cooling, but also the gadolinium is also used for the pyroelectric effect, using thermoelectric effect energy of the like the pyroquartz crystal, by thermofluxing the pyroquartz crystal to exert energy. So that would also continue the circular constant voltage and current within that field, alongside the horns, which will also emit within a wavelength, and as of the foundation, which is aluminum, it pushes the aluminum foundation backwards. And while it pushes, all I have to do is turn my hand around in order for it to lift me in the air. Now the speed that I wanted to run is about, it should be at up above 40,000 RPMs. And so that the electrochemical battery will assist. The same similar as the electromagnetic train. We're using a magnet, a permanent magnet, coupled to a 1.7 AA battery or AA battery, and sent through a coil, where the coil does not have to receive a DC or even a synchronous metallic bond. However, but in a magnetic field, it will flux because of the ions that jumps off, while the two magnets coupled to both the positive and the negative, achieving a charge, causing the electrons to pass through the coil. However, that not receiving a metallic bond, now increasing the heat. Similarities are within the magnetic field, and the coils within the magnetic field, local to it, they synchronize and create electrofluxes. The repulsive behavior against it will cause it to lift up into the air, away from the weight of its gravity, and a lifting of its inertial mass, self-lifting. So, my name is Jermaine Morton. I'll be back to show you more in the gauntlet, and have a nice day. Goodbye. I'm working on the Mark 42, and I'll be back, and I shall accomplish this. Good day.